I'm Dmitri. I'm at Trigit. We're using Go pretty extensively over there. So I'm going to talk about Go and GopherJS. An overview of the talk is, first, I want to talk about what if we could compile Go to JavaScript. What would that look like theoretically? Then I'll say that, well, GopherJS can kind of do that pretty well. Lots of demos and examples, and then I can answer your questions regarding performance, the code size, the debugging, and all that. Okay, let's talk about Go.
Speak up.
Sure. So if you can't tell from the Gopher on my laptop and my T-shirt, I'm a big fan of Go. I think it's pretty great. How many of you guys have used Go? Just show of hands. Great. Okay, that's going to make this a lot easier. So when I saw this code, I knew I had to put it in, but this really summarizes how I feel. Go is a general purpose language for building simple, reliable, and fast software. I feel that is a pretty good description. It's fun to write, and it's a good fit for many use cases. And I also feel that it's a good language to be writing libraries in. Why? Because whatever library you make, it's easily available. If you're writing Go code, you just import it, you can go get it, and makes it easy to distribute. And it's also available on multiple platforms. So there are these packages that abstract out the platform-specific implementation details. So like if you're using file path, then it doesn't matter if you're on Linux or Windows. Oh, sweet. OK. So I can use this now. The idea is that your library just uses file path, and it works fine. And there are all these general interfaces that you can use. So if all you really need to do is stream some data in, you can use IO Reader. And there's a virtual file system interface. So those are great. Now, with that, Go can already target OS X, Linux, Windows, ARM. It's sort of, you can release code for Android in 1.4, and iOS support is supposed to be coming in 1.5. There are others, and more can be added. So do you see like one thing missing in this list? Okay, let's talk about GopherJS. It's a compiler from Go to JavaScript. Its main purpose really is to give you this opportunity to write front-end codes using Go, and it's still going to run in all major browsers. In theory, there could be more than one, and there actually is at least one more Go to JavaScript compiler. So really, I feel like it's an implementation detail, but GopherJS is a pretty cool compiler, so I'm going to talk more about it. I think I'll just have to put this on table here. So here's the repo for the GopherJS. It has 2,000 stars, 100 watchers. It's been around for a while, and it's made a lot of progress. It's written in pure Go, and it can actually compile itself. So there's a GopherJS playground that I'll maybe show later on. The main question you probably want to see answered is, what is supported? And the answer is, it's really nearly everything, including Go routines, channels, and the select statement. There's a compatibility table you can look at. Right, so here you can see all the standard libraries, and where it says yes, those are packages that have support, and the tests, the actual Go tests, are passing. There's quite a lot. Of course, things like OS or maybe runtime, yeah, this works partially. The compiler will do some heavy lifting to make Go routine supported. Of course, JavaScript does not have concurrency built in, but this will allow you to write normal Go code that's idiomatic, and it will still work. Now, I want to show you how easy it is to get started, because a lot of the time, I've seen this project a while ago, but I never actually tried it until just one day I decided, OK, let me try it today, and then realized I should have done this sooner. So first, I'll just make a quick HTML page. So we'll have a script in here. Okay, so let's save that on my desktop. And now if I look at this, well, it's just index page. There's nothing there. Actually, that script doesn't exist yet. So let's make it. We'll write it in Go, though. So GopherJS lets us do println, which is kind of this debugging printing function. It'll have that so that whatever we println will go into the console. So let's say hi. So I'm going to go get it. I already have it, so it's actually pretty fast. And then you just do Gopher. It's basically just like the Go tool, but you can just do GopherJS build script.go, and that generates the script.js file. So then when I refresh this, we've literally printed hi just now. So I'm going to make some more changes here, but before I do that, having to recompile this, it works, but it's kind of tedious. I want to be able to make changes to the code and then see the results a little faster. So what I'll do is I'll use my own tool that basically lets me write this. So it's a little command that I wrote, GopherJS serve HTML. I give it the HTML page, and it basically scans this file. It finds all these scripts that have text.go as their type, and will kind of internally compile the Go to JavaScript and then substitute, basically place it in before serving it. So when I do this, I can now refresh this. Well, I do have to go to this location though that it's serving at. And now I can see hi, but if I change the script to say like hello, then I can see that right away. So let me show you that Go routines work, because that's kind of the fun part. So let's make a channel. Okay, and I can do something like time.sleep. And when I save, that adds the time. Thanks, yep. Okay, so when I refresh, we'll see that it says hello. After a second, it'll say world. Okay, so that's pretty cool, but we can only go so far with just printlning stuff. So first, let me talk about why should I even go on? Why is it a good reason to try to use Go on the front end? Well, there are really many reasons. Node.js, they had a similar idea. They wanted to be able to share the common logic and common code between the front end and the back end. They used a different language. Now, for me, I feel like this is a really cool part, but there's a lot of familiar tools that you can keep on. If you're already writing Go code, you can keep on using like Go FMT, Go imports. Go doc is a big one. You can do Go tests, so you can write your tests the same way that you would write for Go codes. You can actually do benchmarks and compare, is this implementation faster than the other? Familiar types, this is really cool. You can actually have a uint16 that will behave that way. There's no need for an equality table. Compilation errors. That means if you're refactoring, and usually just like with Go codes, when it compiles, it will typically do what you want. You can do the same concurrency, Go routines, blocking, receiving, so you don't have to do the callbacks. You can actually block, do something that takes time, and then continue executing. So here's another cool reason. There's a lot of really cool Go packages that can be very easily compiled to JavaScript and perform what they're doing. So here's an example of Go parser and Go printer, these internal Go packages. And here's a function written in Go that parses the input and then basically prints it out. And very quickly, I can have that running in the browser. So this is that code running inside of my browser. I think I'll make this not full screen so you can see it. I'll just start typing a new basically Go source file, and as I'm typing it, I see that with every keystroke on the right, it's parsing it and compiling. So it's kind of cool. You can see how the parser handles incomplete inputs. And you can see that if I type like 4, this will kind of format that. So now it's a correct program. One way I can know that this was compiled with not 1.4 but the previous version is because this is not supported. Okay, so you can sort of see that this works. Now, that was a somewhat simple package. You can actually do a lot more. So if you're familiar with the Black Friday, it's a markdown parser and renderer. Blue Monday is another Go package that is for sanitizing HTML. Then let's add syntax highlight on top and a few more to basically create this. So I'll close that. But basically right now we have a live markdown editor inside the browser. This is not talking to any backend service to do its job. So I'll clear that. So one thing that it does is if I can format my markdown on the left-hand side so that it's nice. So that table becomes formatted. That's one feature. I can write some Go code. So there's that. I can still sort of format that again. This also supports diff files. So it's doing all that highlighting basically in the front end because that functionality already exists in the Go packages that I've mentioned here. So on the next slide, here's what it really took me to make that HTML page work. Really, it's effectively one line. It's output, set its inner HTML to the result of the GitHub flavored markdown renderer. Okay, so if you had told me maybe 2 years ago that here's like a working compiler from Go to JavaScript, it's absolutely perfect, it does everything, go ahead, use it. I would be like, well, I don't really know how to use it. Like it's kind of an odd thing to have. So because the browser, it's a strange execution environment. So you have your browser, there's some JavaScript you can write, but what can you do and what can you do about it? And again, to come back to my previous point, to do interesting things, you need to be able to do something except just println to the console. So the key realization is that the browser really is a collection, when you're on a web page, it's a collection of APIs that are available to you, the biggest one being the DOM. But there's a lot more that are there. There's the XHR if you want to make those kind of requests. There's WebSocket API. There's WebRTC. That's pretty new. There's WebGL, geolocation. All these APIs are available to you. And typically, it's always been you have your Java code, JavaScript code that is accessing these APIs and doing whatever it is that your application wants to do in the front end. So of course, to be able to do that, GopherJS, it has a way for you to access those APIs. So for example, if you want to achieve the effect of document, this will be JavaScript code, document write hello world, this is how GopherJS allows you to do that. So if you look at this Go doc page, it's an internal package that you import. It's called github.com, GopherJS, GopherJS.js. And it effectively has a very useful object variable. Okay, it has a var global. This is what you'll most likely be using. And it's basically the global objects, usually window for browsers. And it has the object interface. So this lets you get, set, delete things, et cetera, et cetera. So this is how you would be able to achieve that. So you get the document, you call write with hello world. You can also kind of do this other thing where you have an existing Go function and you can basically expose it to the rest of your JavaScript codes by doing set, and then now you're setting in the JavaScript world effectively some function to be whatever you've written here. It's using whenever you go between like the Go types and the JavaScript types, it uses this type conversion table. So here are the Go types. Over here you have the JavaScript types, and you can effectively make those conversions. They're somewhat expensive, so of course you should try to avoid doing it if you can, but you have to. So what ends up being is that now you have potentially Go code on the side that you could write and compile it to JavaScript, and you can access these same APIs that you would with JavaScript. So you can start doing more things. But you don't want to have to do that kind of code that I've shown you before, because this is like writing this in JavaScript is a lot easier. On the other hand, what is possible is to write these wrappers that basically present Go, very nice, potentially idiomatic Go interfaces on top of the APIs that the browser has. So we'll start off with the DOM API. There's a package that basically does that. It's going to be a huge one, as you can imagine. This is the entire DOM, but this is a Go package that you can import and start using it if your code is running inside the browser. And you can look at how to use its API. It's definitely well documented and fairly straightforward to use, and it works. Like, this is tested code. There's a package for the XHR. This one is a lot simpler, but if you want to do an XHR request, this is what you have to do. It's basically a low-level wrapper that mimics the JavaScript API. And here's like a helper function to make it a little bit easier. There's a WebGL API, so you can potentially do something with the graphics, et cetera, et cetera. So you can look for more over here. But with that, you basically have the ability now for your Go code to access the nicer Go packages that expose that functionality that you're interested in. There are also bindings for JavaScript libraries. I'm not going to talk much about this because I haven't actually used much of them. I know they exist, like the Go AngularJS. It's used in GopherJS Playground. You can take a look. I don't know much more about it. And if in case a library you're using doesn't actually implement something, you can always go to kind of the JavaScript directly. So here's an example. That DOM package, it basically implements everything except the history. So like I couldn't do that. That's not implemented, so I just basically did it directly with the JS global object instead. So you're still able to do that. Just want to talk a little bit more about the GopherJS project. So it's developed by one guy, effectively, Richard, and he has some incredible response times for issues. So by now, it is a pretty complete project. So if somebody reports like a bug or an issue in the compiler, it's pretty rare, but when it happens, he fixes them pretty quickly. So there was an issue where it took him 14 hours to fix like a serious compiler bug. I think that's pretty impressive. So just to give you an idea of the state of this project, like a year and a half ago, maybe less than that, just over a year ago, this was still the roadmap back then in 2013. So like he still wanted to implement all these things. The reflection was not complete. There was no Go routine support. You couldn't even go to. All these things are now done, just to give you a better idea of the status and the progress that it's made. So it's still an evolving project, but it's definitely made a lot of progress. Okay, I'm going to change the topic a little bit and give you a slightly different demo. So here's an OpenGL app that I made some time ago. As you can see, it's very simple. It's just like a little toy project. Just one file, just main.go. Let me run it for you. So as expected, it's just a desktop application that starts up and it renders this terrain. Now, what would it take for me to be able to run this in a browser? And this was something that I wanted to do a long time ago. And it turns out, in this case, not a whole lot. So what I'm doing here is I'm using two packages that are somewhat different. There's the GoGL and there's GoGLFW. So what GoGL is, it's basically an OpenGL-like interface that actually has two backends. There's a browser backend, which is basically WebGL, and there's a desktop one, which uses OpenGL 2.1. And the same idea for GoGLFW, this is typically a library that lets you create a window and get input from it and stuff like that. So that now also has a backend for the browser. So if I do GopherJS serve HTML and there's an index page, this is now that exact same Go file that you saw previously running in my desktop. It's now running in the browser. Okay, here's another one. So this is another small demo. It uses a package Go Collada. This is a Collada 3D file format loader. It is a pure Go package. So when I saw it, I thought, well, let's see what happens. Does it work? And it turns out that it does. Okay, that's going to be the old one. Here's the new one. So now that's loading a 3D model in the browser. The reason that it works is going back to my mentioning of sort of general interfaces, is it has two functions that let you load the document. One of them is you're giving it a file name. So obviously that's not going to work in the browser. The other one is you're giving it a reader. And I'm actually able to provide a reader by using the XHR request that gets it from the file system in the back end. But this lets it work in the front end. And so I'm actually like, these are small sort of demos that are parts of a bigger project I was working on. That is also something that I can run in the browser now. Oh. Okay. So this is basically putting together the terrain and the model. And here we have that model, little track. And it's not a finished game yet, but yeah, you can kind of move around and stuff. But to really like demonstrate the point that this is pretty cool, I'm just going to show you. I have a branch here. Okay, so it has one commit on top of the previous branch, and it's basically a place where I started working on the physics. So as you can see, it's just one commit, and all it is, I'm just modifying, velocity, the position. There's nothing specific to the browser. There's nothing specific to the desktop version of it. It's just the logic of the program. And if I serve that again, so now we have physics. Okay, it's a beginning. I'm getting there. But nevertheless, it was that easy for me to make it work in the browser. I didn't have to do anything special for it. All right, so here are some other demos of people trying out GopherJS for some things. Here's like this, sort of like the matrix effect that's running in the browser. This is also using GopherJS to make it work. Somebody wrote a very simple Pong game, so that's what it looks like. And you can run it. This works in the browser too. You can look at the source code and see that it is indeed, okay, I'm not good at it. You can see that it's written in Go. So that's the source. Very simple things, but it's basically using the canvas and drawing those rectangles, and you're able to have that running in the browser too. Oh, and one more thing is GoTools.org. This is a project that I've worked on. It's basically a website that shows you all the shows you the source of any Go package. This also uses GopherJS for all of its front end stuff. Like the idea was that I wanted to try it out. I mean, previously I was showing you graphics related stuff, but I wanted to see what it would take to achieve something if it's if I need to access the DOM or do something like that. So this thing on the right hand side here, that is implemented in Go, works fine, and you can also navigate to different symbols, again, using Go. Okay, let's talk about compile errors. just to give you a better idea as to what it actually feels like when you're developing using Go for the front end. So if you do something silly like this, you're giving an int and it's expecting a slice of bytes, you're going to get a very obvious error. Cannot convert int, untyped int constant to slice of byte slice. If you're going to try to convert or assign this to an IO reader, it doesn't implement IO reader, so you're going to say you cannot do that. These are just like very similar errors to what you'd expect from Go. What does debugging look like? Say hello to println. I mean, you do get panic stack traces, but very often you'll just print things and you're going to see them. But really, like static type checking and these compilers that you get in the first place, they really catch a lot of things you would have to debug otherwise. But just to give you a better idea, here's I've purposefully inserted this panic in the middle of some very deeply nested code. And when that happens, you get an uncaught error demonstrating the Go panic. And then if you look at it, you get a very nice stack trace. So you can see that it went inside of main, process, markdown, second pass, etc., until it went to inline. And if you look at the actual generated source codes, this is the GopherJS output effectively. It's non-minified, by the way, here. That's what it looks like. So this looks very similar to the original Go code that had the panic, which makes it very easy for you to go back in and debug it. The performance. Okay, well, it's not going to be faster than handwritten JavaScript, but at the same time, it's not a whole lot slower. And as I found, it's definitely acceptable for most general use cases. And very often, I did try to push one time. I had, I think, like 50,000 div elements at the same time, something like that. It was basically DOM manipulation that was really hurting the performance at that time. So you can also do things like guild test -bench and profile your JavaScript codes that you end up getting and see like how performant it is. If you really need to, and again, this is definitely a viable thing, to achieve performance, if something is slow and it's in a tight loop, you can actually just use JavaScript for that, do whatever it is you want to do, and then use GopherJS for all the other things. There is ASM.js support planned. There's an issue about it, but it's not yet done, and who knows what will happen in 50 years from now or 35. So, yeah.
The benchmark there, that runs on actual, like native Go, not in the JavaScript part of it.
Do you mean this benchmark, guild test bench?
Yeah.
Right, so there is a mode that uses Node.js, and it will run the JavaScript, but it's going to use Node.js. It's not going to be in the browser.
Okay, that's still better.
Yeah,
Closer.
yeah, it gives you something. There are some performance tips, like if you care about performance, you might want to do a few small tweaks, but again, don't really worry about these until you really get to a point where you have to worry about it. So, but some basic things will be like use the M flag, so that's minify, and definitely apply gzip compression. I will show why on the next slide. And there have been huge improvements made. So if you remember that little pop-up box that happened when I was in Go City Play 95. So when I was here, so this part, it took like 2.5 seconds to load. I kind of use it as a benchmark, so 2.2 seconds. And this is very kind of slow, unoptimized Go codes that I purposely left that way just to see what happens. So it takes 2.5 seconds. On the other hand, the native version of it, I think it takes maybe 200 milliseconds or 100. Let's see what happens. Yeah, it took 86 milliseconds. So it looks like it's about, an order of magnitude like 10 times slower. So now, when I started off, this was actually taking 30 seconds in a browser. And I made an issue about it. I said, okay, it's taking 30 seconds. That's kind of long. Can you take a look at it? And Richard did, and he ended up making quite a few improvements. And basically, at the end, here's like a table of comparison. It went from 30 seconds originally to 3 seconds without really any changes, just optimizations. And it takes 13 seconds on my iPad to load the same page. So I guess my MacBook's a little faster. But it's interesting. You can compare performance of like your mobile device with your desktop. Size of the generated code. So I have a table here. You can take a look. But basically, when you have a very simple whole world application, it will have a fixed sized overhead because it has to do all the sort of bootstrapping work to make it work for all the Go codes. But then if you add more code to that, you're going to add more just same type of code, it will not get much larger. So here's like a simple Go file that doesn't use any imports and ends up being 12 kilobytes in the end. When it's using just FMT and a little bit of code, it's 89, but then you add more code, it's still 89. But then the biggest I've seen it get, like if I import every single package I can think of, it ends up being, and this is like 11,000 lines of Go codes all at once, it's in the 200, 300 kilobyte range. So it's big, but it still works in the browser. Some limitations. The biggest one right now is, even though concurrency is supported, you do have to mark some of the blocking codes as basically, like you have to add this comment, GopherJS blocking, to let it know that this is a blocking code. This only happens when you're basically passing in an interface to a function, and basically when it's compiling, it looks through the Go code that you've written, and it tries to figure out which of the codes could be blocking. But when it's an interface, it cannot know at compile time if it will be blocking or not, so you have to do this thing. And it could be a problem if you have something in the standard library that you cannot modify. But yeah, there's ongoing work to make that better. That is really the biggest issue right now. Yep. This is like maybe 2 more. Yeah. So yeah, this basically prevents you from implementing blocking IO reader and netcon, which is kind of a shame because if you could, then you would be able to like basically implement netcon using a WebSocket and then drop that in and then use JSON RPC package. And you could basically implement the HTTP client by giving it a custom transport that wraps around XHR. All these cool things that are not yet quite doable, but maybe soon. Yeah, of course, if you're going to distribute an app that uses this, there's going to be more steps. You have to now compile this Go to JavaScript, but maybe you can use Go generate with that. If you're loading an HTML page, it's best to have just one of these GopherJS compiled scripts in there, because if you have two, that's kind of, you're going to have the overhead of 2 Go runtimes effectively. It's still young and evolving, but as you can see, it's pretty, it's pretty advanced by now. So there's maybe less people familiar with Go than JavaScript, okay? But some advantages are you basically get to use Go, and I think that is the biggest advantage. So if you feel you want to write Go code and run in a browser, then GopherJS is for you. But I mean, really the takeaway message that I want to give you from this talk is that really, like, which language you use in the front end, whether it's JavaScript or potentially Go, it's really a choice you have to make. You should sort of investigate the trade-offs and see what you want to do, what you enjoy writing more, etc., and think more about, like, if somebody makes a pull request for this repo and it's in JavaScript, and what is it going to look like versus what if it's in Go, and what if I have to deal with this 2 years from now? So really, it's completely up to you. But I'm definitely having a lot of fun writing Go code in the front end, and I see that there's still more things you can do to make it better, but it's a pretty cool thing to be doing. So you can, something to try at home is play with the GopherJS playground and maybe think of a Go package you like and see if it can be compiled. Here's a community page, more community stuff you can find. It's basically in the GitHub repo. Thank you very much. Yes?
So how does the compiler compile blocking code? Does it compile continuation or?
Right. So basically, how does it handle the concurrency and all the blocking code, because JavaScript's not supposed to block, right? The way it does it is, and I'm not an expert on its internals, but what I do know is it analyzes all your Go code that can be blocking, and it effectively uses closures to kind of save state. If you get to a blocking point, it saves the state and it kind of unwinds the stack and returns. And then when it resumes, like it will basically see if there's another Go routine that could be running instead, et cetera, et cetera. So it really does have to kind of save the state, unwind the stack, and then resume either another Go routine or just return to the browser.
Was there any thought given into like putting it into web worker and then having an async bridge with the main thread to do it?
Right. So web workers were definitely considered when Richard and we were discussing like what are some possible ways to implement concurrency. You cannot really like web workers are kind of more heavyweight than Go routines, so you cannot do a one-to-one mapping. But there may be some other things you can do about it. But it was something that was discussed, and they're not used at this time.
And then just to solve the blocking issue, because like if you put it in web worker, you can block it.
Right. Well, all I can say is that they're not using web workers right now, but it was definitely considered, and it could be revisited in the future. But you should take a look at that issue where it was discussed and see what you can find. Is that a question?
Yeah. If you have in your code, does GopherJS pick that up?
So if you have a Go compilation, like an error in your Go codes, GopherJS would actually give you an error. So it will look like something that I've shown here. Well, okay, that's a panic, but.
The one before. So it looked like it showed up in your.
Oh yeah, so okay, I kind of skipped over this thing. So what happens, the tool that I was using to make my life easier, when there's a Go compilation error, it basically just makes this like mock JavaScript file that just does like, console.error and then just dumps all these error messages for me so I can see them in the browser. Yeah, so this like basically in this case there was no proper JavaScript generated. It's just
So these are the actual.
yeah.
File.
Yeah, these are compile time errors that GopherJS generated, but they do end up in the browser for visibility, really. But this is not a runtime error of JavaScript.
We got time for one more question, I think. Or two.
Are there conditional compilation flags for JavaScript platform?
Conditional compilation flags?
Yeah, you see.
Right, yeah. So GopherJS definitely supports that and respects that, and that's how I was able to basically have these like an OpenGL-like package that had different backends. So when you're compiling it on your desktop, it's using like OSX build tags, and if you're running in the browser, so it uses the JS as its architecture, so you can use that as the build tag filter.
One more here.
Have you seen anything with React.js in this?
I think somebody was working either on bindings for it or playing around with it. Like I think I've seen that recently, but I don't have more to say on that. But it's definitely a cool thing to try.
All right, big round of applause. Thank you.